This chapter, quadratic, I'm telling you, needs rigorous practice. Hi, my dear Matholics. Welcome to Sarvottam Diksha.
So let's quickly see what and all we should revise in quadratic equations. Quadratic is a degree 2 polynomial which when I equate to 0 becomes an equation. So this is the standard form of quadratic equation. Here a should not be equal to 0 because the moment a become equal to 0 it will become a linear equation. So let's see what kind of question generally they can ask about quadratic equation. So here we have to check whether these equations are quadratic equation or not. See here we have to simplify each and every equation. If it is a MCQ, we need not to solve it till end. We should solve only for x square term. Like here I know I will get a 2x square. The first term if I multiply, I will get 2x square and here I will get x square. So when I will simplify, since the coefficients are not equal, it will remain as quadratic. It is a quadratic. Let's check option B. I am having x square and here if I multiply I will get x square minus 4. I need not to check other, it will get cut. So it is a linear equation. This is not a quadratic equation. Here I don't think x square will get cancelled by any other thing. So it is a quadratic equation. It looks cubic because I have x cube, but when I open it, no need to open it fully. I know it will be x cube minus 27. We know the a minus b whole cube formula. And this x cube will get cut. And this 4x square, when I will simplify, x square term will be still present in the equation. So it will be quadratic. So only b is not a quadratic equation here. Then they tell us to find the roots. As we have already discussed in polynomials, roots, zeros and solution are the synonyms. In case of polynomial, we use term zeros, and for quadratic, mostly here in this chapter, we will use roots. Now, what is roots? We know that that particular value of x for which my entire equation becomes 0 is the root of the equation. How many roots my quadratic equation can have? We know from polynomial chapter that the graph of quadratic equation is a parabola, and the point where parabola intersect x-axis is the zeros. Reason being my y is 0 on x-axis. So at these 2 points my y is 0. So a quadratic can have maximum 2 zeros, but it can have lesser zeros also. Let us see what are the conditions. Sometimes the turning point of parabola touches the x-axis. So I have only one root over here. And sometimes parabola turns before intersecting x-axis. So no roots here. So to see what kind of roots are there, do we need to find the roots? No. There is a term called discriminant. D is b square minus 4ac. If my d is greater than 0, then I have distinct and real roots. D equal to 0, I have real and equal roots. D less than 0, I have no real roots. So we have done relation between the graph and the discriminant also. Basically, if you see, if my d is greater than equal to 0, I have real roots. Here roots are equal, here they are distinct. That's the only difference. We call it nature of roots. If in the question they are asking you nature of the roots, you have to simply find d, and according to value of d, you have to decide what kind of roots you have. So basically they are asking you, out of these 3 options, what kind of roots your quadratic equation has. Now let's see how this concept works. We know that roots can also be given by quadratic formula minus b plus minus b square minus 4ac upon 2a. Now just see this term. This term is nothing but my discriminant. This discriminant and this term is same thing. So now if this is having distinct value, so I will have 2 values, 1 to plus and 1 to minus with b. So I will have 2 distinct values. The moment this becomes 0, if I do plus minus 0 also, it's the same thing. And square root, if it is negative, square root of negative numbers, for example, if I take minus 41, is not possible, because for no 2 numbers, if I am doing square in real numbers, they will give you negative number. Negative into negative, positive. Positive into positive, positive. So square root of negative number is not possible. So here, there I don't have real roots. How this formula comes? It's done by completing square method, which was there in our portions till COVID. It got deleted after COVID. Let's see the equations based on this concept. Here I know that this is my A, this is B, and this is C. Simply I will substitute the value in my B square minus 4AC. This since my roots are equal, I will put it equal to 0 and I will solve it. Eventually I will get this AD equal to BC only. The equation looks query because it has big terms involved. So main thing what they are checking here for you is the patience. So keep solving it patiently, open your brackets properly, and you will get the end answer. There are many these type of questions. Please do practice at least 2-3 before exam. This is very important type. Generally it will be there in your exam either in MCQ or as a 3 marker. Now see this question. Here thing is with variables, how will I show my square root is positive? Let me solve it. I know that this is my A, this is my B, and this is my C. Let me substitute the values. Here since my C was negative, so I have put one more bracket. I know that this minus and this minus will be positive. So see what I am getting now. So do you think I should further solve it? Most common mistake students will do it. They will open the brackets. They will apply a plus b whole square formula, a minus b whole square formula. No, I need not to. Here this term is a square. So square of any term, whether a plus b is positive or negative doesn't matter. This term will be positive always. Same way a minus b, whether it is positive or negative, this term is also positive. And sum of two positive numbers is always positive. So it means my d is greater than 0 over here. And if d is greater than 0, then it means it has real and unequal roots for sure. And why it can't be 0? You can say, ma'am, a minus b, a plus b can be 0. They have clearly given me a is not equal to b. So both of these two terms are non-zero terms. So my d can't be 0 also. So it's real and unequal only. So basically if they are asking you real roots, try making squares. And if it is equal, then your d should be 0. Then they ask us to find the roots. How I do? First method is factorization. And second method is quadratic formula, which is also called Sridharacharya formula because he invented it. They may mention it to find the roots by factorization method or quadratic formula. If they have not mentioned anything, then it's my choice. I can do with any method. Let us see factorization method first. Now here how to factorize when your coefficient are in square roots. I know I have to see first what is your s. Your s should be minus 2 and your product, I have to find two numbers whose sum is minus 2 and product is root 3 into root 3. So here when I multiplied root 3 and minus root 3, take this minus, I will suggest you take separately only, it will help you actually. Take minus 1 separately. So basically 3 into minus 1. So and take one of the factor as 1 also. So sometimes it helps you, like here also in this equation if you see, I will use it as minus 3 and 1. Because when I add it, I will get minus 2 and when I multiply it, I am getting minus 3. So I have to split it as minus 3 and 1. Now here when I take root 3x common, what I will get? I know that 3 by root 3 is nothing but root 3 only. So here when I take root 3x out, I am left with x minus root 3. And here I will take plus 1 out and x minus root 3. So I have got the two factors. So once I have got the factors, I will equate each of the factor. This we have discussed already in very much detail in polynomials. Each of the factor I will equate to 0 and my roots are minus 1 by root 3 and root 3. So here my a and c were having square roots. Now let's see when middle term, the b is in square root. S should be minus 10 root 6 and p should be 10 into 15. When I factorize further, 2 into 5 and 5 into 3. Now here just see one thing. I should have root 6 in sum. And when can I get root 6? I can get root 6 if I add two root 6 terms, like root 6 plus root 6 is 2 root 6 or 7 root 6 minus root 6 is 6 root 6. So if I multiply this 2 and this 3, I will get 6. And I know that root 6 into root 6 is 6. I have to make two group of the factors. Let me split 6 as root 6 and root 6. Now if I add or subtract, so root 6 will be there in my answer. Now what is the other thing left? 5. So if I give 5 here and 5 here, 2, 5, I have split it like that. My sum is 10 root 6. But I have here minus 10 root 6. So what should I do? If I multiply minus minus, I know that minus into minus gives me plus. And if I add it, it will give me minus. So I will take it as minus 5 root 6 and minus 5 root 6. Here 5 will come out. And I still, what is left here? 3. And 3 I can write as root 3 into root 3. This root 6 I can write as root 2 into root 3. So I will take root 3 also out. Root 3. And what is left now? Root 3x minus. Only this 2 is left now. So I have root 2. Now here what I will take out? I will take here 5 root 2 out. So if I take 5 root 2 out, I will get same way root 3x, because I have taken minus out, so my signs of all the terms inside will change. It will be root 2. So these are my factors, and after equating both of the factors to 0, I will get my roots. So I am seeing that roots are same here. This 5 can cut. Why I can cut 5? Because now I am realizing when every A, B, C, all three have 5 common. I could have taken it out common also. Let's see third type also. In factorization, when your coefficient are square roots, here all A, B, C are in square roots. So my sum should be minus 2 root 2 and product should be root 3 into 2 root 3 minus 1. I told you have to take because it's a minus sign here, and 1 you should include. Now in product, if I multiply root 3 into root 3, it will become 3. So this I should multiply. Reason being, my sum is having root 2. It is not having root 3. Now this 2 I should split. Actually this is what I have now. And this 2 if I split in two groups, root 2 and root 2 I should write. Because now sum or difference. Now whatever I add here will give me root 2 for sure. So I had minus root 2. So let me multiply 3 and minus 1. So minus 3 root 2 and plus 1 I will give here. So if I add, I will get minus 2 root 2 only. And product is same as what we wanted. So this, with the same method what we just discussed in the second question mentioned here, I have factorized it and I have got the roots. Now let's do same questions with quadratic formula. We know my quadratic formula is given by minus b plus minus b square minus 4ac upon 2a. Here I will suggest you to find discriminant separately rather than finding full thing together. So this term is called discriminant. We have just discussed. So it is, I have substituted the values. Let me quickly solve it. Oh, I am getting it as 0. Yes. When I solved with factorization method, I got the equal roots. So D is 0 over here. So if I substitute the values, it is minus 2 root 2 square. So after solving, I am getting D as 2. If I substitute the value, it is minus 2 root 2 plus minus root 2 by 2. As I said, they won't give us simple equations to find the roots. Here my coefficients are, if you see, in variable form. To be honest, those students consider it as a tough, but this is the easiest form. How? I know this entire thing is my C. I know how to factorize it. So after factorizing, I am getting b minus 5 and b plus 4. So what should be my sum and product? If I add these two factors, I have only two factors. So if I have to make the group, see what is happening. If I add these two factors, I'm getting 2b minus 1. But again, I'm having minus 2b minus 1 over here. So what I will do, if I put minus in front of both the factors, my sum will be negative, and since minus minus will be plus, my product will be this only, b minus 5 into b plus 4. So this is how I have done the splitting. Now after factorizing, let's see what we are getting. So keep all this in brackets. Otherwise we'll make mistake with plus minus signs. Actually it's the easiest. Only two factors, you have to just adjust to get the sum. You have to look for the minus, plus and all. Now this third one is very important and students find it very tough. Basically they get confused in factorizing this constant term. Do one thing, for some time take a as x. So this will be easier for you to factorize because we are used to of factorizing with x, right? When a comes, we get a little confused. This you can factorize. Just solve it and write your answers in the comment box. If still doubts, let me know please. Now see these type of questions where the equation doesn't look like quadratic in a glance, but it can be reduced into quadratic. Let me see the first question. So these two terms are reciprocal of each other. If I consider this as a, then my second term is nothing but 1 by a. So I can write it as a plus 1 by a equal to 13 by 6. Now when I take LCM and all, see what I get. Now I have reduced it into a quadratic equation, and when I solve it, I will get some value of a. That value of a I will put for x upon x plus 1, and again I will solve and get the value of x. So here this is not quadratic, but I have to do cross multiplication. This is the most ignored question. Students think they can do it directly in exam, but please do practice. I will suggest you to do all 4 of these questions once before exam 2. Then only your pen will keep flowing in exam also. Here again this is something different. Just split. I know that 2 raised to power a into 2 raised to power b when base is same is 2a plus b. Generally we go from left to right. I can go ulta also. So this I will write as 9 raised to power x into 9 raised to power 2 minus 6 into 3 raised to power x into 3 plus 1 is equal to 0. So now 3 raised to power x and 9 raised to power x. Are you seeing any connection? Yes, if I further write it as 3 square x, I can replace 2 and x also. I'm not writing full equation. Directly I am taking it as 3 raised to power x square into 81 into, I can multiply this 6 and 3, 18, 3 into x plus 1. So let 3 raised to power x is a. So what I am seeing, I am getting a 81a square. This 81 I am writing before as a coefficient. Here I have 18a plus 1. Now again it is a quadratic. So after getting value of a, I'll put it equal to 3 raised to power x. After solving, I am getting a as 1 by 9 here. Now 1 by 9 also I can write with base 3. How? I will write it as 9 raised to power minus 1, which is 3 raised to power minus 2. Now I will compare, since the base is same, I will compare the powers, and my x is minus 2. So there are many other questions of this type. You can practice it. So this type is also important. Now word problems are also very important part of this chapter. The same type of the questions which I told in polynomials are important here too. Only condition will be of this kind, you will get quadratic. There you get linear. When you start framing the equations, you get linear equation, 2 variables. Here you will get quadratic. Concepts are same. I will discuss both the word problems together in upcoming video. See you in my next lecture. Bye bye.